Hey guys, this is Professor Janacek. I want to go over some examples of the vector operation cross product. So let's start with a couple of vectors. We've got vector u is -4, 1, 0, and vector v is 0, 1, -1. And example 1, let's find the cross product of those. So remember, the cross product of two vectors is the determinant of a matrix. Now, to make this determinant, we're going to start with the first column being I, j, and k. Those are the coordinate unit vectors. The next column, our next row, is the first vector. In this case, that's u, or the components of it. And the third row is the components of the last vector. All right, now we have to remember how to find the determinant of this matrix. Remember, to do that, we'll start with the I component. We get rid of the row and column that I is in, and so what's left is 1, 1, 1, -1. And so that's going to be the I component. Oops. Let's try that. Minus, for the j component, again, there's j. Oops. We're going to get rid of that row and column, and so we're left with -4, 1, 0, -1. That's for j. Plus, notice the alternating signs here. For k, get rid of that row and column, we're left with -4, 1, 0, +1. That's the k component. Now we have to remember how to find the determinant of a 2 by 2 matrix. So what we're going to do here, these are really diagonals, top left to bottom right, minus top right to bottom left. So for the I component, that gives us 1 times -1 minus 1 times 1. Minus, for the j component, we'll have -4 times -1 minus 1 times 0. Plus, for the k component, we end up with -4 times -1 minus 1 times 0. Whew, all right, so with a little arithmetic, we end up with -2i minus 4j and let's see, that ends up being plus 4k, which of course we could write as -2 -4, 4. Oh, but you know what? I realize I did make a slight mistake here. That should be a +1. Back. Which makes this one here a +1. Oops, so that gives us -4k. That's better. All right, so -2, -4, -4 is our resultant vector. Whew, all right. Well, again, not a very difficult process, but a little bit tedious. Watch those positives and negatives. Lots of things can easily get lost, as you can see. All right, on to number 2, we're going to take a look at v crossed with u. Notice the only thing I'm doing differently is I'm just turning that around. Instead of u cross v, we now have v cross u. So why don't you try this? Give that a shot and see what you come up with. You can pause and start up when you get that done. Have fun. All right, so going through all that, you should end up with the vector 2, 4, 4. Again, take your time with that arithmetic. Can be a little tricky. But notice that these are not the same. U crossed with V and V crossed with U. There is a connection there you might be able to pick out, but they are not the same. And so realize that this cross product is not commutative. So notice that U crossed with V is not the same as V crossed with U. All right, on to the next one. Let's determine the area of the parallelogram with sides of U and V. All right, so to find the area of a parallelogram, if we have these two vectors as its sides, we're simply going to take the magnitude of U crossed with V. Well, we already figured out what U cross V is, so we want the magnitude of U crossed V is this one right here. To find the magnitude of that, it is the square root of the sum of the squares of each component. So that's -2 squared plus -4 squared plus -4 squared. Take a moment, do all that computation. It's not too bad. I think we end up with 6. So the area of the parallelogram that has U and V as its sides is 6. Now remember, U and V are in three dimensions, so to kind of visualize this parallelogram might take a bit, but we know the area. It's 6. All right, now let's take a look at example 4 here. We have a force, that is a pound and a half that's applied in a direction that's perpendicular to the screen of a laptop at a distance of 10 inches from the hinge of the screen. Find the magnitude of the torque in foot-pounds that is applied. All right, so we do need to remember how we find the torque. Recall that torque is, the formula we wrote down was R cross F, and more importantly, the magnitude of that torque is the magnitude of R times the magnitude of F times the sine of the angle between them. So we have to kind of figure out what's going on. Where is our force? Where is F? Where is R? So let's see. First off, we know that here's the hinge. That might help. And this force is being applied at the top of the screen 10 inches above that. So there's our force. And of course this distance here is our 10 inches. All right, so to remind us what this looks like, remember this force is F, and this distance here, that is vector R. So if you remember the situation, we've got something like this. So here is R. There's vector R. There's vector F. And so what we're looking for is the torque here at the hinge. If you remember defining this, r can be defined as the vector going from point O to point P. That might help. Okay, so let's see, what do we have? Well, to begin with, we're going to need R and F. Let's see, so we need the magnitude. The magnitude of R, well, we know the magnitude of R, that's 10, but this is in inches. And remember that this is supposed to be in foot-pounds. So we have to change this to feet. Remember, 1 foot is the same as 12 inches, so we're going to multiply by 1 over 12, gives us 10 over 12 feet, which we can reduce, and we end up with 5/6 of a foot. All right, how about the magnitude of F? Well, the magnitude of F, that is the 1.5 pounds, which we can go ahead and write as 3/2 pounds. Okay, so far so good. And finally, we do need the angle between them, but we are told that this is perpendicular, so we know that theta is pi over 2, 90 degrees if you will. All right, so now I think we're ready to find, we're just looking for the magnitude of that torque. That's going to be 5/6, and that, by the way, is in feet. Times our force, which is 3/2, that's our pounds, there's our foot-pounds, and then the sine of pi over 2. Well, let's see, if we multiply and reduce, and of course the sine of pi over 2 is 1, so we end up with 5/4, and again these are foot-pounds. Well, that wasn't so bad. Hope you enjoyed.